Good morning, everyone. This is Jason with DTK. We'll give everyone another minute or two. I just want to say good morning. We do have the chat open. Somebody will be replying to your chat throughout the presentation, so you don't actually have to hold the questions till the end. If any questions come up, feel free to type them in the chat. We have somebody answering that as we go through. We'll get started in a minute. Thanks. Okay, well, it's 10 o'clock. We're going to get started. It's a little awkward for me. I'm used to doing these in front of people, but under these challenging times, this is the new normal, I believe, for a little bit, doing these webinars. As we said before, anyone that wasn't on the call, Mike Molinari, our general sales manager, is working the chat during this webinar. Tomorrow we'll be flip-flopping. He'll be giving the presentation. I'll be manning the chat. So any questions throughout the presentation, don't hesitate to put those on the chat, and we'll get going. So again, greetings to all of you. This is the 2020 DTK webinar series. Again, I'm actually in the factory today. I don't know those of you that know DTK. We are still manufacturing here in Florida. We are doing our safe distancing. We're alternating shifts in the back, but we are still manufacturing products here in Florida. So just to let you know, I'll show you a picture of the factory in a minute, but I want to let everyone know that we are still working and manufacturing goods in Florida. Going to talk a little about what we'll cover here today. We're going to talk about DTK as a company, a little bit about what are surges and spikes, the causes and effects of those, terminology related to surge protection. We'll also talk about how surge protection works. There seems to be a lot of questions out there in the last 15 years of my travel. How does this work? Is it like a thermos, hot or cold? Does it just know when it works? We'll talk about the technology that goes inside of it and how it works. We'll talk about codes and standards that drive some of these parts into different applications. And then we'll talk about the right surge protection parts for each application. We'll cover IP video, CCTV, fire alarm, network communications, UPSs, access control gate, intrusion, and AC power. We'll also talk about installation rules. Those are very important. Mike, who's also manning the chat on this call myself, have been in DTK combined over 30 years. We have done a ton of site surveys. I would say some of the most important part of the presentation, based on who I know is on here and signed up, are installation rules and grounding and bonding. We can both attest, as to some of the people on this call, over the years of doing site surveys, the majority of the time we're called into the field because of improper installation. I will not accuse anybody. I will say it seems to me that a small percentage of people actually read the installation instructions. So we want to talk about that. That is a big focus. We want to end with that because we want that fresh in people's mind as they lead the presentation, as well as, grounding and bonding. So those are very important in this presentation. We'll talk a little bit about DTK. This is our 32nd year in business. We founded in 1988. We are veteran owned. We do manufacture. I think it's around 98 to 99% of our products here. The only things we import, obviously, battery backups, plug-in strips, anything for, that you would hook up to a network, fire alarm, things like that you plug in RJ45 or hardware, we do make here in our factory. We are ISO 9001 certified. At the bottom, you see the Tampa Bay Top 100 Workplace. I travel the country all the time, and I've seen thousands of people a year for the last 15 years. And everyone always talks about the culture, and I've seen some great companies, and I've seen some companies with some strife internally. One thing I can tell you about DTK is we do once a year a little potluck. And we have 88 employees here, I think, currently. 60 of us have been here longer than 5 years. So that should tell you a little bit about the company and the family that we work for. So I always like to tell people, who you're working for, the company you're dealing with. This is our team. This is our manufacturing floor, and this is actually it in action. So I always encourage my customers, hey, if you ever want to evaluate how our stuff's made, we have an open door policy here. Aside from current conditions, we encourage people to come and take a look around the factory. We have high-speed manufacturing lines all over. You can see them right here. We do make stuff in-house. When you talk about some of the featured customers and projects, these are just a few from different types of industries. I mean, obviously, we do well with all kinds of school districts from K through 12 into university level. We deal with a lot of end users, whether it's corporate, whether it's C-store, oil, gas, property management, auto industry, grocers, obviously the government we work well with, and we put bank stadia up there because a lot of our site surveys that we've done over the time have been in stadiums, and every single one of these customers you'll see on the screen, we've done actually feet on the street site surveys for, which we offer all of our customers. So just give you an idea of some of the marketplaces we're in. Talk about what are surges and spikes. They're temporary increase in line voltage on any type of electrical circuit. Any metallic conductor can carry one of these surges. It causes damage, degradation, and it can destroy your electronics. You talk about the different types of surges, transient voltage surges. There's two definitions of a high impulse of voltage or current, and that can be tens of thousands of volts in positive or negative polarity, and short duration. These are only microseconds. These are different from temporary overvoltage. A transient voltage can be positive or negative, and it's in microseconds. Temporary overvoltage is positive, and it can be seconds, even into minutes or hours for temporary overvoltage. So totally different events. Types of surges and spikes: impulsive and oscillatory. Impulsive are your atmospheric stuff. That's where a lot of people hear a lightning bolt, see a lightning bolt or hear thunder, and that's what we consider impulsive, atmospheric discharge. Oscillatory seem to be the larger cause of surges in most properties. These are capacitor switching, inductive loads. This can be pumps, motors, drives, HVAC, chillers, different things that start up, like that elevator motors. Whenever they turn on and turn off, they tend to generate surges inside of a property. And now you'll just see the different, what causes surges and spikes. A lot of people associate surge protection with direct lightning strikes. We do not protect from a direct lightning strike. I can't stress that enough. I have personally worked with a couple large commercial insurance carriers over the last 15 years, and I've been called onto some sites where they have had extraordinarily large claims, and they've called us out there to, hey, how would we prevent this in the future? And we even have some insurance companies that will pay up to $25,000 proactively for surge protection to protect certain properties. Obviously, these are the proximity strikes, the second one that we're really trying to protect from. The one that hits maybe a couple streets over, up to 2 or 3 miles away, depending on soil conditions and the atmosphere. You also have utility grid switching and brownouts and blackouts. Internal causes, when you go into the internal causes in the building, we show a picture of a copier here, but obviously, it's not just going to be the copier. It will be HVAC, motors, drives, things like that. I live in Florida, and I can tell you as a small little example, people might have seen this before. I know before my AC is going to kick on because my lights dim just a little bit. As these things get up to speed and turn off, they just, dissipate that excess current voltage around any type of property. The bigger the chiller on the roof or the side of the building, the bigger the transient when it goes off. Copiers are notorious for these as well. A lot of times people will think in a finished office environment, I don't have to worry about surges, but they're created inside the building the majority of the time. Some people say 3/4 of the time or more, surges are internal. And then you've got human error. We show this cloud ground lightning map for a couple reasons. I did a different webinar with people yesterday that had them all over the country. We were talking about different sections of the country. And if you'll see here, just an example, we were talking yesterday, I was talking to somebody in Chicago. If you look at the coloring, it could be green to yellow, which could be 3 to 6 or 6 to 12 strikes per square mile. Well, based on soil conditions, if it'll learn a couple miles underground, all of a sudden now you're dealing with, 6 to 12 turns into 12 to 18, maybe 18 to 24 events a year, depending on the soil conditions and how far it's traveled. Even out west, where we traditionally don't have a lot of lightning, I have heard, and based on our sales, I can see that there's power quality issues out there that does still require surge protection because the power might not be as clean as some of the other environments we see. And again, anyone in California, I'm not beating up your infrastructure. I'm just saying what I've heard. The effects of surge and spikes. Now, these are real important. Degradation, that's gradual deterioration over time. We use analogies, or I do a lot of time when I do trainings. The degradation and the smaller types of inductive loads tend to be like jabs to a system. If you've ever seen a boxing match, those are the jabs. If you get jabbed enough, everybody knows you're going to fall over and probably not make it till the end. Destruction or the proximity strikes tend to be like a knockout punch. You get hit with one of those things, and I don't care if it's a couple streets away or a mile away, your equipment could be fried, which leads to the destruction and then the downtime part of this. I have so many horror stories that I could tell people that would scare them into submission. One of the big ones, and I know looking at people on this call, there's a couple people on this call that took part in this. I had a hotel in Florida a couple of years back take a surge at a Fogo de Chão across the street on International Drive. It was 4 blocks up and across the divided highway. it hit that place, and you could look at that map real time, and it got into their PIV, which took out their fire alarm system. It also got into their lighting, and it took out all of their IP systems. Biggest thing, the destruction was 250-something thousand bucks. The downtime part, those of my fire alarm partners on the call know that when their fire alarm's down, you got the fire watch out there. So the local jurisdiction parked the fire truck out front, charged $150 an hour, and it was out there for 17 days. So those are real losses that can't be recovered because of downtime. I've had people in, I guess, industry. I've had a plasma cutter go down, $50,000 machine. Forget about just the cost, but the downtime of it being down because they didn't spend the $80 to put something on the disconnect. So it's, you know, you have to think of all these things, not just destruction, but the downtime as well. When you get into terminology of surge protection, I'm not going to go too far into this, but maybe not at all. Want to let you know that there's different terminology. MCOV is, you know, maximum continuous operating voltage that device can handle. VPR, these are ratings that all surge detectors have. These are based on UL 1449 clamping tests. You also have nominal discharge current, which again are done through UL testing. Must be fully operational, all these tests, and then obviously grounding and bonding. These are terms we'll talk about, you know, a little bit more throughout the presentation. How surge protection works. This is a, I guess, a simple drawing, but I can't make it any simpler to show you how these devices work. You'll see a copper circuit here. In this device, we have a patch cable. This could be a 100-meter cable. This could be a 25-foot cable. Let's just assume it goes outside of the building and touches this camera. Obviously, you see the surge coming down the line. When you, without surge protection, it gets right to the camera. When you install one of our devices, in this case, you know, an MRJ POES, now the surge gets grabbed, shunted to ground, and then self-resets for the next event. Real important to know, all our devices do self-reset. I cannot give you a quantitative amount of time, how many times they'll self-reset, depending on the environment they're in, the severity of the surges, and how many surges they take, but up to 20,000 amps, they'll self-reset on that device. Talk about how surge protection works. This is an oscilloscope, and obviously you'll see the diagram on the left has no surge protection versus the one on the right. If you'll notice that red numbers on the right-hand side of these pictures, you'll see the delta in voltage that got through. 4,200 volts or 4.2 kilovolts on the left without surge protection is definitely going to fry some equipment. On the left, surge protection knocked down to safe 800 volts, so there's a little pass-through, but that equipment is definitely operational still. Going to the components in these devices, those of us that have been around for a bit, remember the old MOV devices? That's what everything had, 15 or 16 years ago when we started. Now everything's kind of progressed on most of our AC products, all of our AC products, to thermally protected metal oxide varistors now, which have a high surge current rating. They have an internal safety disconnect, which keeps them from getting hot and melting and smoking like we used to see in the past, and it degrades slightly after each transient. So we've gotten a lot safer in 15 years. You don't see big devices blown out of the side. You don't see them going into conduction and melting like we've seen in the past. So they've gotten a lot safer with these thermally protected metal oxide varistors. When you get into the low voltage applications, we tend to move away from the MOVs because they add resistance and they're slower response time. When you get into the networking products, we want to use an SAD-based device, which is a diode device. Extremely fast, really quick clamp time, but they don't handle a lot of surge. So if we only had a single stage in there, we'd be popping these devices all the time. So what we do is we use those steering diodes in tandem with a gas discharge tube, which has a really high surge current. So we steer it into this device, which has a 20,000 amp rating. This has a slower reaction time if it were by itself, but in tandem with the silicon ambulance diode, is quick responsive, very low capacitance on the circuit, because we're going to get asked a lot probably if we haven't seen it in the chat already. Can you put these on a 100-meter circuit? They're almost invisible. The dB loss is very little. Talk about codes and standards. A lot of our surge protection, installations are code driven. You've got on the fire alarm side, you've got anything from, NFPA 72, 2013, which a number of my jurisdictions are still on. We have NFPA 70, which is the Bible. We talk about listed surge protection devices on fire pump controllers, which hasn't always been there. 760.32. That's just obviously your circuits running outside the building. Those should always be protected, especially SLC, NACS. And the things that I see forgot, the one that I see forgotten a lot on a fire alarm system seems to be the PIV, which is attached to a big, huge metal pipe, whether it's out by the street or in a riser room. But a lot of times that one seems to get left out on surge protection. Of course, something's going to hop onto that and come right into your building because it's attached to the biggest metal pipe probably on the property. So just something to throw out there as I go through. NFPA 70, which is our National Electric Code, obviously, on any emergency systems, SPDs are required now. Should also be required, provided any facility low voltage distribution levels for critical operation systems. Should be installed in wind electric system and any load served by that system. Industrial machinery with safety interlock circuits shall have surge protection. Shall also be provided for critical operations data systems. So a lot of these things have changed. In the past, a lot of these should say should have surge protection, and now they say shall. I think safety being the issue. When you talk about the 2020 edition now, any services supplying a dwelling have to have SPDs. So in the past, again, it was, the right thing to do is probably throw one on. Well, now all your new construction should have one of these things on here, shall have. The SPD has to be part of the service equipment or immediately adjacent to it, and then it must be type 1 or 2. Real quick little synopsis of type 1 and 2. People who've been around a bit, the type 1 used to be called like the arrestor, will go on the line side. Type 2 used to be like a TSS on the load side, but we'll get into that in a couple slides. Now we'll call it SPDs. When you get into UL scopes for AC, and this is 120 volts and up, obviously all our devices are UL 4th edition listed. We've got 3 different types, like we talked about a little bit before. Type 1, that one's permanently connected on the installation, the secondary side of the service transformer, and on the line side of the service equipment. So if you were to put that on your residential panel, that would be on the line side. Type 2 is going to go on the load side. That's going to be your 2-pole breaker on your residential or a 3-pole breaker on a commercial service, and you'll hook it up to one of those. Type 3 is point of utilization SPD. That's normally, more than 30 feet away, and that could be something like your branch circuit coming to your fire alarm panel, or that copying machine on the other side of the building that, is a $5,000 or $6,000 copying machine. On the low voltage stuff, these are primary like communication circuits. UL 497 is just primary protection for building entrance by NFPA 70. 497A is communications lines. That's more or less the old POTS lines. And then 497B is anything else low voltage. Our speaker circuits, our PoE, our intercom circuits, SLC NAC, those all have a 497B listing as well. Talk about SPD location requirements. Obviously, you've got one at the main service coming in. Utility fed power obviously is the main spot where surge can come in to a property. You never know what's coming from that pole. Most of these things are above ground, or if it's a nicer neighborhood, they're buried below ground, which is even more chance for them to bring them into your building or house. You could also put it right at the circuit panel, receptacle outlets, more than 10 meters away. There's also type 3 over there. So these are locations. So one of the things we also like to cover is when we're dealing with, end users, and I've done a lot of joint sales calls, as have most of the DTK team here, with integrators. And one of the things, we hear a lot from the integrators, I don't want to include surge protection and get priced out of the job. I'm in sales. I've been on that end where you're looking at bids, and a lot of times, if there is no surge protection in the bid, I understand that if you do the right thing and add 3 or 4 line items, you might be the one that is at, over by 300 on the last page, and sometimes that's all they care about. So a lot of times my integrators will win a project, and then they'll say, hey, I'm going to recommend surge on this project. I just won, a $40,000 job out here. You've got no surge spec in. You've got cameras out there. You've got intercoms out there. You've got, fire alarm between buildings, and this stuff has to be protected. And if you don't want to, that's fine. We provide this tool to our dealers. It's almost like an uninsured motorist policy. And I provide this to our integrators. They put their logo on the top, and they just hand it to the customer saying, I'm doing a project out here. I feel it's going to be susceptible to surges. And before I leave, I just would like some acknowledgement that we offered surge protection to you, because a lot of us who are in the integration side, and I don't know who's on this call, but I'll use it as an example. I have found by doing joint calls, sometimes in a property management type facility, the person who makes that immediate decision is not the one that we hear from when it hits the fan. So it's nice to have that CYA type of thing in case somebody else goes, because the first thing that they might say is, well, I never knew this could happen. Well, this document protects you from when it does happen, or it sells a little bit of surge on the front end. Especially right now in these times, we all want to make every dollar we can, add the surge on, get a little bit of extra profit, get a little bit of extra protection, and at the end of the day, we're doing best thing for our customers anyways. Second objection, customer doesn't think they need surge protection. This is probably one of the funniest ones I see. And I mean, honestly, everybody understands the need for, a strip behind your TV, a battery backup under your computer. It's crazy that people don't understand that they would need surge on something that would leave the building. So this should be a relatively easy thing to say to them. Again, everybody understands the surge need in their house. It's the same thing in the property, except it's, higher dollar investment. Cost of surge protection as a percentage of the total system is too high. This is completely misleading. Again, if you tried to make a system bulletproof, which we've already talked about is impossible because of direct lightning strikes, but if you were to call DTK out to a site and we gave you a complete site survey report with everything from service entrance to low voltage protection to lighting controls to battery backups, all soup to nuts, I mean, the entire package, you're talking about less than half the sales tax. So I really don't feel that it should price anybody out of a job. If you really understand and voice your concerns to your customers about, hey, you do have a chance of, the downtime knocking everyone out of your network and you guys not being able to work or make phone calls if you're all PoE phone systems, or if something did come in and take out your network from a surge. Those are real conversations to have. And again, a lot of times people are protecting the image or the data as much as the actual protection, the camera. I still have protectors sold all over the world for analog. Sometimes they're more than the camera, but people want to make sure that that data is still being recorded versus something happening. Okay, my customers don't need surge protection. We never get lightning here. Well, like we talked about before, less than 25% of the surges in any property are caused by lightning events. You've got inductive loads, which are the big one. You've got utility grid switching, which happens all day long. A lot of people might not realize, but in the evening, as we all travel to the residential areas, they do a lot of grid shifting to shift the power management to those neighborhoods. We don't need them there during the day. In the mornings, they start to do shifting from these different substations to feed all of our commercial customers. As that happens, you are not getting a clean power feed. It is a roller coaster all day long, and I don't think anybody would argue with me on that one. So I just want to let everybody know. Surge protection applications, we'll get into individual applications. Obviously, it's typical building system, whether it's exterior lighting, fire alarms, HVAC, access control, IT, electrical distribution, anything that's going to touch copper, we're going to have a surge protector for it. When you get into IP video surge protection, we've tried to simplify this. If you were to just look at our line card or look at maybe like a quick reference guide of ours, you'll see a number of different parts. It can be, maybe a little bit overwhelming. I can tell you we've made it so simple with some of these documents now that you're really never going to choose between 3 or 4 parts per individual application. So great, I'm doing an IP video product. I'm probably not going to have to choose between like 5 or 6 different products. So we made it pretty easy. This is the general diagram of the parts on an IP system. If you look on the left, we show 2 different parts. You've got a DTK, MRJ, POES, and those of us that have been around a bit, I know are historically really good at selling the MRJ POE. Mr. JPO has been around forever. Mr. JPO is still here. I would encourage everybody on this call or webinar to add Mr. JPO's older brother, the S. And the reason being it's shielded. The simple fact of that is, it will still accommodate plastic RJ45 and unshielded cable, but we would now, if you are running a shielded cable on this installation, you have surge protection at both ends, you don't have to ground that surge protector out at the camera end anymore, which can be pretty tricky. I've done a number of site surveys where just grounding these devices out in the field can be a real pain in the neck, depending on, making it tamper-proof. Where am I going to find a good ground? If you're running shielded cable, as you know, you can't ground the shield on both ends anyways. So it'll reference shield on that end. On the other end, it'll give you shield ground, and it'll take all the surge protection to ground at the head end. So let's start using the S version on the end. We still have the MRJ PoE, but I'm just saying we have the S version that'll accommodate shielded or unshielded cable. We also have a PVP IPS, which you'll see kind of in the back left of that. Same type of circuit on the RJ45, but we give you additional terminals for accessory or camera power. And those are 24-volt terminals. We do have a version going through UL in the future will come out with higher terminals, so like 56, 57 volts. We have some projects out there that need higher voltage based on maybe like a fiber project where they have Siamese cable for power. So we'll have a device that will accommodate, the power for those circuits as well. If you look over on the right-hand side, this is our device in the NEMA 4X enclosure. The ones on the left, they've got to be put in a box. They don't want to be exposed to the elements. The one on the right, the MRJ PoEX, that's in a NEMA 4X enclosure. You'll see cord-type grips on that picture. They actually come in a little Ziploc bag inside of the device. So you can actually pipe conduit right into this chassis, or you could, put the cord-type grips on and it'll tighten around your cable and give you a water-type grip. Once this device is mounted in the field, the cool thing is if it ever does self-sacrifice, those 4 screws you take off the front cap, there's just a simple little edge card you pull out, drop it in the trash, slide a new edge card in, put the cap on, plug your cables in, and you're good to go. On the rack mount device in the bottom, we'll go into that a little bit further, but you'll see a 24-port head and equipment. Each one of those is individual modules. Again, I'm looking at the list of attendees. I see a lot of folks that have been around for as long as I've been around here, and we appreciate all that. Historically, we had an RM12 PoE that we still sell quite a bit of. I don't know if it's people don't know about this one, but the ports come in the back and they come out the front. If they self-sacrifice, you have all 12 ports, populated, you got to take it out of the rack. You got to take the top off and replace the module. It can still be done, but with these new devices, as you'll see here, the top of each one of those little modules is a little slot. You can stick a dime in there, turn it sideways, and pop one of those 10 gig modules out, hot swap in less than 2 seconds. So it's pretty cool. We also have, here's a typical installation, I guess, application drawing, and you'll see the other rack mount devices at the other end. Obviously, you want to put these on both ends. That's a question we get asked quite a bit. I think, and this goes back to how do I really sell surge protection to my customers? On an IP camera installation, it should be really easy. Sometimes people are apprehensive about putting surge on this stuff. It's really crazy, but you've got an IP camera on the top of a pole. If you were to take that same cable and unhook it from the camera and put a phone out there on that pole, well, now you have to cover it. So that should be an easy way to tell your customers, listen, if this thing were a pole, I'd have to have surge. I just changed it to a camera, now I don't have to. So something to keep in mind. And a lot of people, when you explain it that way to them, it's eye-open. So yeah, if surge is introduced on one of these copper cables, this red path that you see here with the lightning bolt, it goes both directions like a ground source, which is why we protect both ends. When you get in the RMNETS series, this is a new product for us, new product series. You'll see a 12, a 16, and a 24 channel. Obviously in the 12 and the 16, if you'll notice, those little blank spaces in there are just plastic blanks that you can pop out. So that RM12 net S, in theory, could be a 16, an 18, or even up to a 24 net S if you kept adding modules. It comes with 12 from the factory, just like the one in the middle comes with, 16 ports from the factory. And obviously on the top comes fully loaded 24 ports. These are 10 gigabit modules. If you'll notice on the bottom right-hand side, we do have a module for EXT-MS. This is for extender circuits. Extender circuits tend to run proprietary voltage over different pinouts. Our traditional net series is for 48 volt PoE or data protection. So we're looking for plus or minus 3 volts on data and 48 on PoE. So we have a 72 volt clamp for the PoE and then 7 and change for the data. Extenders, if you're throwing 57 or 58 over different pinouts, it's going to be an issue. So we have an extender module for this. We also have an individual device like an MRJ PoES, but EXTS. We don't sell a ton of them, but the option is out there for protection. I'm going to show this quick video, hopefully, and this shows you basically how this thing is replaced. This is basically somebody in our rack. I think we use a screwdriver here, but I literally have used a dime. You turn that module out, that's how we use this. Just pop it out and replace it. Get yourself a new module, slide it in, plug in your RJ45s. Pretty nice to work with. When you get into, I guess you would say, smaller applications or maybe smaller portions of a larger job, we have 4 and 8 channel NetS series. Obviously pretty self-explanatory. These are all same hot swappable. If you look in the little tops of those modules, you'll see that little slit I was talking about where you can stick a dime in and turn it sideways. 4 and 8 channel, I think historically people thought, okay, smaller installations. What we found on most of these are actually going into fiber projects. A lot of times you'll have fiber running out to an IDF box, and let's say you might have 4 or 8, 10 cameras, whatever, coming out of that. A lot of times, well, not maybe only cameras, it could be a wireless access point, any type of IP appliance that's coming out of an IDF box, a lot of times is either outside or in like a warehouse environment, which we've seen a number of those in the site surveys we've done. You'll have fiber running out to an IDF box where it's converted through into a switch, and then they have cables running to cameras, access points, different monitoring stations, what have you, throughout these warehouses. And the cables are most times Velcro tie wrapped to the metal infrastructure of the roof. So in those applications, great, it's fiber to the IDF box, but then you have copper running either out to a fence-mounted device or a pole-mounted device, or even internally in a lot of these warehouse scenarios, you've got them to a metal infrastructure on the roof. So we still find a need to protect those devices in the IDF box. This is basically to show you how these devices work. Obviously, your field wiring comes in the top, and then the wires come out the bottom into your protected PoE switch or whatever your appliance is. This is at the other end. This is the inside of that MRJ PoEX. I wanted to show you earlier how we can actually replace one of these. If the cap were taken off, you see that solid, probably about 2/3 of the way up. There's a solid black line there with the RJ45s. That's the only thing you pull out of that slot. Replace it or send it to us for testing, and you're good to go. So either way, you can throw it in the garbage. If you feel that it's an issue, we can always take it back and give you a written lab report on what went wrong with the devices. We still do offer a lot of analog protection. We have CCTV, HD CCTV over analog. I still have a lot of customers that require this. We also show on this slide, if you look in the bottom in the middle, the DTK POC, as well as the RM16 POC. I have a number of large worldwide customers that still use Ethernet over coax, so we have these devices for that. I don't want that to get slipped by. We still have a lot of customers that are doing that. Obviously, for the analog stuff, I've got PTZ camera protection with all your RS-45 controls and power at the top. In the middle, we've got fixed cameras, and then we also have ones with Balin's built in if you need be. So if you have HD SDI, well, then you'll need the IBNC HD, but I see very few of those. That is it for the IP section. Hopefully, if anybody has had a bunch of questions, Mike has been doing a great job of answering those, I'm sure. If there's been no questions, that means I'm doing a great job, so I'm taking all the credit. When we get into the fire alarm side of it, pretty straightforward. And this can be any manufacturer's panel. This is just a random red panel sitting out there. I can tell you that this could be a black panel. It could be a silver panel. It could have different numbers manufactured. It doesn't matter. They generally all have the same type of circuits coming to them. We're going to cover the ones on the left first. Obviously, SLC, NAC, anything that leaves the building, it's absolutely got to be covered by code. We have had a 2MHLP series, the B series, the 24BWB, historically has been our #1 selling part for those low voltage applications for SLC. What we found over the years is some of our customers said, hey, I would rather have a device that instead of when it self-sacrifices, shorts the ground and puts me in ground fault, I want one that opens up. So what we've done is, in our 3 phases, we went from, our 3 stages. We have a diode, we've got a gas discharge tube, and we have a fuse. On the F version, it's a 1 amp fuse. So if that device were to self-sacrifice, that triggers that fuse to open up. So now you know exactly which devices aren't talking to each other. It's a lot easier to diagnose for the service techs. They're not hunting out the ground fault, divide and conquer, start in the middle, do a continuity, divide that, do a continuity test. With the F version, when they don't take you to ground and they open up, which 2 modules, which 2 panels aren't talking to each other. Same price, same fit, same function. Just keep in mind, it does have a 1 amp fuse, which why you see at the bottom, the NAC is always going to be with the B version. If you run a 3 amp NAC through that MHLPF, that 1 amp fuse is going to cook the first time you put it through it. Over on the right, you'll see external antenna kits, distributed antenna systems, maybe an antenna on the roof. Distributed antenna especially has to have surge protection. So we have external antenna kits. Phone lines, I know there's still phone lines out there. POTS lines aren't even brought up in the 2019 code at all. There's still a lot of people use them, so we have protection. Whether it's the one on the right that we've had forever, a lot of letters. MRJ31X is just how it connects. SCP means it has a fuse, and then WP is with patchwork. One next to it is just hardwired. When you get to the bottom, here's where we've really made a lot of progress. The one on the right is a device we've had for a long time. Still one of our top 3 selling parts. 120HW LOK is this version, comes the lockout kit for the panel. Everyone knows the DTK 120HW. These devices are great. I've seen these in the field for 15 years. One thing I have noticed, as has most of our team and most of the integrators, and looking at this attendee list, I can see at least 8 of you in the top 25 that have gone through this same experience with me in the field. Somebody gives me a call and says, hey, I'm on a multi-building complex. I've lost a few buildings. I can't figure out why. Okay, great. I'll come up there and do a site survey, regardless of where it's at. We go out there, we look at a few panels. What do you know? We find that 3 of the HW, the lights have gone out. Well, inspection wasn't for another 6 months, so it's a good thing we were out there, because as a parallel device, it's not going to trip power to the panel. The light goes out, and it's almost like a tree in the forest. Does it really make a noise? I don't believe a lot of people are putting eyes on this. I would encourage anyone on the fire alarm side that can hear me, go and check to see if it's part of your punch list. Even make sure that light is still on a fire panel. I would say 50-50 when I'm in the field. When I ask service techs and I ask inspection crews, like, hey, is it part of your punch list to make sure the HW light's still on? And they all just kind of look around and look at each other. So I think it's left off quite a bit. So if you're using those, I would just say, for your own sake, make sure the light's still on, because if it's not, the next surge that comes through cooks your panel, and then the customer is looking at you going, okay, why did I pay for this surge protection? And then I get the phone call. So what we've done is we've come out with our DF120S1. This thing is groundbreaking, patented technology, stuff we've never seen before. You know, not only is it a 120 protected device, it also has a UL 1283 listing, which is important. That's EMI and RFI filtering. So let's say you're in some type of installation that might have a lot of harmonics or noise on the circuit. This will actually filter that as well. The other cool thing about this is if it ever does self-sacrifice, if you'll notice on the module on the top, it's got 4 different LEDs. It's got 1 to let you know it's energized, cool, it's got power, 2 that it's grounded, you want to know that, and 3 that it's good. The module is still working. If it, for whatever reason, does not work and self-sacrifices, all of a sudden you'll see right below it, it's got a little tricked out red light that'll start blinking. It's also got a very loud audible alarm to let you know that the device is self-sacrificed. It also, if you'll notice from that picture in the bottom left, you'll see one of the caps over a knockout that have dry contacts, normally open, normally closed dry contacts. So if this device were ever tampered with, lost power and or self-sacrifice, it's going to report to you via that monitoring module or whatever you have it hooked up to for a trouble code. And this is a lot easier to sell to our customers because now, you know, with the dry contacts, you can actually program into the panel, depending on the manufacturer, it could be 10, 20, or 40 alphanumeric characters to say, hey, AC protector blown. So anybody walking by that panel knows exactly why it's in trouble, and they're going to call you, and I can tell you from experience, customers are never unhappy when you're out there to replace a surge protector. You know, that's a good call to have to replace one of my widgets versus going out there and saying, ooh, I'm sorry, we got to replace 5 or 6 boards. You know, this isn't the day of 15 years ago where you had one addressable panel at the main spot and then everything was cheap conventional panels reporting back to it. Nowadays, majority of places I go, they're all addressable panels. And add in voice evac, you know, mass notification and things like this, these printed circuit boards are in the thousands upon thousands of dollars. This is nothing to offer a protector that's really low cost, but it'll let you know if self-sacrifice so you can go out there and replace your protector versus replacing the board. I think I have a video here to show you how this guy works as well. I don't know if the audio works, but again, this is in its normal state, assuming it's working. I think it's slow to develop, but it'll land its plane. So when this module expires, obviously, the light turns red. Somebody comes out to replace it. Okay, it'll also report to your panel. There you go. Perfect. Now, in the past, none of this would happen. If you had a 128W, the light would go out in some closet somewhere, and no one would ever know until maybe an engine inspection or the next surge cooked it. Turn the breaker off, pop the module out, stick a new one in. It's key guarded, can't put it in upside down. That's it. That's it. And for my low voltage fire alarm contractors all over this call, and I can see you on the attendee list, in the past, let's just say historically, it has been a challenge for my low voltage contractors under code to replace a 128W. So of course they do the right thing and they call the electrician in. On this one, you can turn off the breaker and you're not hardwiring anything. I don't believe you're gonna have to call that electrician. So keep a little extra margin in your pocket for replacing this device versus calling in a licensed electrician. But we do, you know, hopefully know what you're doing. Obviously this is underneath it. We've got a dry contact terminal there, and this does have an audible alarm that you can disengage. If you notice that buzzer switch position on the bottom right, if you do turn the alarm off, just to you know, silence it, you can't put a good module in there without the alarm going back on. So basically you're gonna have to take the cap off and reset it back to normal. If you do turn this off, it will not behave properly. You have to put it back to normal and have a good module in for that alarm to go off. Again, here's just your dry contacts when reporting to a monitoring module, which puts your panel into some type of trouble. Our 120HW LOK, obviously, you know, comes with the lockout kit per NFPA. We also have a series of devices that combine some of these. The one on the right, you'll see is an NEMA 4X enclosure. Gives you 120-volt protection with dry contact, so it can be monitored remotely. 4 pairs of low voltage protection on the bottom. It's got mounting feet to mount on a wall. Nice clean ground bus, so as you bring your hot neutral ground in, we're going to give you ground for the low voltage protection in one can. A lot of times we spend a lot of extra money and labor on guys fishing around. Where am I going to ground this? Well, right here, it's already pre-grounded in this box. So it'll save you time, labor, easy to find, inspect, and replace post-installation as well. One in the middle is just a TSS1. That's a little bigger device. It's got up to 10 pairs of low voltage protection in that can. If you'll see on the right, it's also got some screws where you can mount more bases or even maybe an antenna protector. I've also seen monitoring modules in there as well if it's properly spaced. So that's our TSS1. It comes with a test module inside of it. Test module is just a pass-through to let you know if you had a module that was failed. One of the things you can also do for my installers out there and my operations guys, this one's important. I don't know if we cover this later. I get asked quite a bit when I do these trainings, how do I know if the surge protector's gone? How do I know if it's self-sacrificed? And possibly I'm not sure we really have a slide that touches on that, but it's really important. With our low voltage protection, and I mean low voltage 75 volts and under, they either work or they don't work. And with these devices I'm showing you, like these MHLPs or like the MRJ PoE, they just stop working. And basically your continuity goes from in to out to ground. So now it's pretty simple. I mean, you just do a continuity test with your multimeter, put it on the ground source and drag it across your RJ45 pins on your MRJ PoE or the RM24NETS. If there's continuity to ground, that device is self-sacrificing. So they're pretty easy to diagnose. I get that question a lot, so I just want to take a break and throw that out there. And any questions, we can follow up with that later. Networking communications, surge protection. Obviously, we've got some different platforms you'll see at the top. We have a 6-channel on a hinged wall bracket and a 12-channel on the left for a 19-inch rack. These come empty except for a bag of blanks like you see on the left. Ports 1 through 4 have the blanks in them just for a clean install. These are where you can mix and match different modules. You could have IP, you could have PoE, you could have maybe a digital extension phone. You could have an analog phone, you could have a speaker, you could have BNC. So it's basically mix and match, kind of build as you go. Instead of having 6 or 7 different devices mounted on a back plane somewhere in a cabinet or a closet, you can clean it up, put it all in one little chassis and have a single point ground, so it's a cleaner install to work with before you install it and if you ever have to service it. Then you'll see a Cat6A series device here for primary protection, and then our UPSs. Typical network installation without surge protection, red lines are bad. Obviously, any one of these appliances or devices out in the field or attached to the building could bring a surge inside the building, in which case it could go from switch to switch to switch, unless you're using fiber uplinks, or just to the switch and then out into different servers and or storage devices, and this is bad times. Properly protected, you've got the devices, and then it's not getting into your network as well. We go into our UPSs here. There's 3 different kinds of UPSs. We offer 2. Do a general synopsis. You've got good, better, and best, I guess you'd say. A good would be a standby device. Has a really low response time. It's got a relay. It can take up to 5 nanoseconds. Those are your low-end entry-level UPSs. Middle of the road, next one up would be line interactive. Now you've got buck, you've got boost, you've got filtering. So it's not just sitting on the side of the road waiting for complete power loss to turn on. It'll buck your power up or boost your power up. It'll buck it down if it's running too hot, and it's got some filtering. It still has a small response time in its relay if it does turn into battery backup. With the top of the line, which is the best, that would be your online double conversion technology. This one plugs into the wall. It's basically rectified to DC to charge a battery. We charge this battery and then basically rectified to AC. So when you plug into the front, you're essentially plugging into the battery. So if it ever loses power, it's seamless. You're already getting continuous sine wave power, nice clean power, and the interruption is 0 because it's already feeding from the battery. One thing we have decided to do a little differently than our competition, when you get into our 15 or 2000 or 3000 VA versions, we include the SNMP card and the mounting rails free from the factory. On the smaller ones, the 1000, it doesn't come standard, but we do have it as an option. A lot of times 1000 and under, you're only doing 1 computer or 1 server, so you don't need an SNMP card. The bigger ones, you might be doing multiple computers and or servers, and you need that network capability to address and manage more than 1 server or computer. But having the network cards and the mounting rails is key. One of the other things for my integration partners on this webinar, this part should really hit home with you guys. And I say this all the time, and I can't stress this enough. Part of the problem you have right now out in the field is you compete with some of these huge online distribution houses that sell directly to end users. I do not sell to those marketplaces. I sell to authorized distributors. So, and again, I have to walk a fine line because some of these slides earlier I showed people as being our customers. They're customers in installation. You saw Amazon's name, they install our parts. I do not sell directly to them. I do not have an Amazon marketplace. So when my dealers and my contractors are out there offering up a DTK UPS, the end user, they're probably not fishing around and finding it all over online and going, forget it, I can get it for online for the same price. And I know being out there on calls with integrators, you can sell great good luck service and a good luck warranty. It's not going to matter. A lot of time, like our place here, we've got a great IT team here. They can do anything they want here. But I'll tell you what, if somebody's offering a product like this, they can't shop around and you can show value and, you know, equal specs. This is a great tool for you guys to make extra margins. When you get into the next line down, and I say this is still better, you know, we're good, better, best. This is better. This is a small, you know, this is our line interactive line. We have a 600 and an 800. The cool thing about these is they actually have a touchscreen LCD. You don't see that a lot of times on a UPS, I guess, for the home or small business environment. So it's got a diagnostic LCD screen that'll let you know, load, battery, and voltage. So that's good. And again, it's got AVR stabilizer, which is that buck and boost. So again, this is, I guess you'd say entry level for us, but it is a line interactive. It is by far no means the bottom of the barrel or the entry level UPS. When we get into the access control space, I would say 50-50 of what I see out there right now is probably still Wiegand protocol. So you have that 3LV-OPX. I know there's still a lot of customers going over to OSDP, in which case you could use one of the MHLPs we talked about before. You know, depending on how many circuits you have coming back, we have solutions for that as well. It could be PoE. I see a lot of these systems going PoE. So as you see these different devices, obviously you want to protect them. You'll see on the far right that we have a card reader protector out of a prox reader. I know from experience of being in the field that to try and sell one of these on a cheap little island prox reader, by the time you add in the parts, the labor, and trying to find a grounded out there, can be a challenge. I can also tell you that I've done a number of surveys with people on this webinar at government installations, at transportation depots, at even corporate environments where they have two sets of readers on one pole, one lower for cars and one higher for trucks, buses, higher vehicles, semis, things like that. Now all of a sudden you've got $1,000, $2,000 on that pole. Now it's a no-brainer to put one of these protectors at the base of that pole. PoE, same type of thing. At the other end, you'll see the 8FF. Still one of our leading selling products. I think one of the reasons is it has space for 6 Class 2 transformers. If you can see in that picture, it's kind of tough, but 3 on each side. It's spaced out so you can do 6 Class 2 transformers. It's also got a bracket on the back so you can mount it on the wall. It's got 144,000 amp surge current rating. And we briefly talked about surge current rating earlier, but you know, as you look at, you can go into any retail store and buy a plug-in strip that will give you outlets and maybe minimal surge current, 400, 600 amps. There's a device that gives you 144,000 amps, so you're getting what you pay for. Then you'll see on the left the ESS. These are basically door strike protectors, mag locks. They're just basically wired in series. You put one right in the door jamb, then one back at the other end. I've also seen these used a lot for like card access on gates for like garden-style apartment complexes. I can't tell you how many times I've seen those things get cooked, even though they're in the middle of 5-story buildings. Those gates and those fences on those pools are notorious for having surges get in and cook the access control panel board. So it's important we don't leave out those part on the left either. Gate access, again, the littlest things can be forgotten. Majority of our customers, I think, do this properly and put something on the power feeding that device. I would say, let's say half, maybe, are covering the safety loop, the exit loop. I can tell you from experience, we had a case not too long ago where somebody lost their gate motors to 2 big, huge gate motors that were 300-foot gates to let planes in and out of somewhere. And because they didn't spend the whatever it was to protect that safety loop, their motor was down. 2 motors. The boards alone were $4,000, but the fact that they couldn't open the gate and had to take a golf cart out there to open up the gate, in that meantime, they went through about $14,000 in jet fuel, all because they didn't spend a little bit of money protecting the safety loop. Again, I get it. It might be aluminum, but it's still a conductor attached to your printed circuit board. And in most times it's underneath the biggest gate or piece of metal on your property. So to think that this would not pick up a surge, I think is, I don't want to say silly, but good luck. If you look over on the right, we have card reader protectors as well. Again, we talked about the Wiegand one. We also have, traditional CR that has an extra pair of terminals at 24 volts. And then we have telephone-entry. Telephone-entry panels still have a high cost. You're going to need an additional pair for telco voltage. So in that device, we give you a pair for analog ring-up voltage. And then, of course, you'll see the MHLP 5V. Those are your dry contacts. So it's going to trigger that gate to open, whether it's a guard shack, whether it's somebody inside the building, or whether it's, card access, telephone entry. Dry contact safety loops, even though they're milliamps or, they're still carrying a pathway to the board. Intrusion surge protection, this slide, We still have it a lot of these times. You know, we have telco protection. Most people aren't really, you know, communicating via central station that way, but we still have ones where you can plug in the transformer and give you power and give you phone protection, or have phone protection on the left. Majority of what I see is only on the right. That 1F, everybody that plugs anything into for any of their customers should be offering this 1F. That's a device that, I tell you what, when I go into integrators and end users, I say, listen, if you don't put a 1F on everything you plug in, shame on you. They're relatively inexpensive, and the surge current ratings is in like the 40 to 50,000 amp range. They're a tank. They also come to real long center screws, so you can actually screw it into your transformer, into my device to hold everything in place in the wall. The other thing we're concerned with, 12-volt remote zones, whatever those things might be. It could be a pole barn with a motion sensor out there, a portable classroom with a motion sensor out there. Maybe you're not concerned with the motion sensor, but you definitely don't want that coming aerial or barrier back into your bird panel and cooking that. So those remote zones, you definitely want to stop those surges coming back into the panel here. AC power surge protection, and at this point in time, I'm so excited. We have a complete range of protections, from everything from small devices to service entrance to disconnects for your HVAC in the side of your house, and everything in between. We have service entrance protection up to 300,000 amps. You know, these are tanks, these are modular, have all the bells and whistles, field replaceable modules, dry contacts, phase loss monitoring. You could have an integral disconnect in here, UL 1283 listing. So basically, these are for your main panel board, service entrance type things to stop the big surges coming in at building entrance. We also have non-modular. Again, you could still put these on your main service, or you can put these on a different panel board. These devices, they do not have a replaceable brick. Like these devices, you would open these, you could replace the brick inside, but they have a higher cost for that. These devices, once they do self-sacrifice, like the D200, it'll take 200,000 amps for that device to self-sacrifice. It also has dry contacts and an audible alarm. We also have a D100 and a D50. D50 is probably our entry-level light commercial, high-end residential protector. We sell, I probably couldn't even quantify, it's probably one of our best sellers in the electrical space. We also have industrial control panel surge protection. I know a lot of our customers out there are doing things in 5-way panel shops and DIN rail surge protection. We do offer a full line of DIN rail surge protection as well. Again, 1449 4th edition. People that do know DIN rail surge protection will appreciate the second bullet point, that we have a 75,000 amp surge current rating. That's up there. Obviously, also, you can't see in the picture, it has field replaceable modules, the part with the little yellow label on top and bottom. You can just slide that little module out and keep the base installed on the DIN rail if it ever does self-sacrifice. And again, it's got dry contacts, remote monitoring, and it's got a visual indicator. It'll go from green to red if they self-sacrifice. Residential surge, you always want to look at your power coming in, your HVAC condensing unit. You could also say, hey, if I have another disconnect feeding a pool pump, you know, maybe a spa out back, that's another area where that HVAC type of device would go. Inside, receptacle surge protection, 7VS. You know, we have 3 outlets with USB chargers, but I want to show people the cable TV one. That one's important. A lot of us, like myself at my house, I get my phone, I get my internet, I get everything from Spectrum, Time Warner, it all comes on a coax cable. A lot of times people forget to cover that, and they say, well, I've got something on my main panel. Perfect illustration. Main panel is in the front of the house. Cable comes in the back. First thing it's going to land on is your router, and then probably all your computers and TVs. It has nothing, no copper on that. It's going to connect it to the main panel once it gets into the power through your television. So you always want to protect all the copper at building entrance, including cable TV and or POTS lines. If there's still folks out there with POTS lines, you want to protect those lines when they come into the building. Full house panel options. Again, we've got ones with flush mount plates. I've got, you know, different sizes on these. These are NEMA 4X enclosures with cord tight, you know, grip nipples on them, so you can have them around in the panel or outside. I think it has a 6-inch flex conduit that comes with each device. And again, 50,000, 100,000, 200,000 amps total surge current rating. We can flush mount those as well. When you're getting the low voltage, you want to select models. Sometimes people look at these charts and they think they're kind of overwhelming. It's pretty straightforward if you look at it this way. Technical specs, we talk about service voltage. Okay, in this case, well, what the heck am I going to put on an SLC loop? Awesome, I want the 2MHLP. My service voltage is 24. Okay, 24F. If you look down, great, MCOV, clamping voltage, and maximum continuous current 1 amp. That's the perfect device for me. Speaker circuit's going to be a little different. Now we're kicking up to 75. Obviously, we're going to have to use the B version now because we know the 1 amp fuse is going to have problems with this. So now it's a 75B based on this chart because that has a maximum continuous current of 5 amps. We've also done a lot of work to put ourselves in master spec. Mike Molinari, who's running the chat, has done a great job of, this was his project. We have 2 different sections of our products in master spec. Obviously, my electrical engineers, guys doing panel board, service entrance type stuff, 280509. Oops, sorry, where are we here? This is our low voltage section. I'm sorry, there was only one slide for it. I apologize. This is our low voltage section, and this will cover fire alarm, access control, and CCTV. That is in master spec. You will see it written around our specification. We also have 264.313, which is your typical service entrance type stuff. These are where we're going to put our stuff into master spec for panel board. A lot of engineers can go into master spec, just say, okay, great, pick DTK by the job, and we'll auto-populate with all the parts we've got. We also have on our website, we have design files. These design files are great on our portal on our website because now engineers can log in and actually take these drawings, we have them in PDF, we have DWG files, and basically put them into your plans. So we've done a lot of the work for you, just carry this over. This is the installation part, and if you'll see part 2, we even show 3 feet. And that's something we'll talk about a little bit later, but surge protection has an inherent response time. You have to give it some cable after the surge protector to give it time to turn on, pull it back from that small gauge conductor to a thick, lower impedance ground, bleed it back off the circuit and dump to ground. So we have installation notes on these drawings as well, as you'll see on the right. So there's that term out there, and I'm not going to say it, but you want to make it something proof. We try with this, but we all know that's impossible, but we try as hard as we can to make it, as easy as possible to follow instructions. These are the notes that come at the bottom of the page. You talk about, grounding, things like that. Same thing on a fire alarm installation. We show all your different circuits where they would be protected. We have CAD drawing examples on there. So basically all of our engineering partners and anyone that's designing projects, we have all this stuff online for you. Best practices, this is probably going to cover everybody. When I go into a company new training, I say it's kind of like the Mercedes symbol. You got 3 things that are all important. Without the tripod, it's not going to work. You got to have sales knowing to sell it based on code or because the customer needs it. You've got operations who has to design it properly, and then equally, if not more important, you've got the guy out there installing this thing. If he doesn't do his part right, the whole thing's for naught. So we want to talk about best practice, things we've seen out there, and things that we should be doing better. We always talk about 3 feet. And basically the way this works is, I give an analogy. It's really simple. I'm a simple guy. Picture a speed trap on the side of the road. If you're that poor person going a little bit too fast, it takes a second for that cop to whip out, track you down, pull you over, and then back up and wait for the next guy to come speed by. Same thing with the surge protector. It gets a little bit past the protector before the internal components react, pull it to a lower impedance ground, self-reset for the next event, just like that speeding cup. You get past them a bit, we pull you back, we dump you to ground, and we get ready for the next event. That's generally how surge protection works. This is a nightmare. Let's really appreciate that somebody spent the time to make a 3-inch patch cord, number 1, non-booted, no strain relief. Clearly, that's not 3 feet like we see in our installation instructions. And then the coup de grace, if you'll notice, not even grounded. So somebody probably spent, some money, a lot of money for a surge protector that turned out just to be a coupler. If you do not reference the ground, and it's a non-shielded device with non-shielded cable, we have nowhere to dissipate surge. So ground is imperative on surge protection. Look a little better here. You'll see 3 feet leads, and this is a fiber project. This is at this is at one of our ports. And you will see fiber comes up into the bottom. It's converted to copper, and then we go from there out of the switch into field wired cameras and access points in this port. And you'll actually see in the middle there, it's got a little bit of, but it's got 3 feet of wire, which is key, and they're grounded. Installation rule number 2. That's a lot to read. I'll keep this really simple. I've been in the field for a long time. Anybody out there that's been in the field or anybody that's done some work at their house has been in the same exact position. You've got 4, maybe 5, sometimes maybe 6 conductors in one of your hands. You've got a wire nut that's meant for 3 conductors in the other hand. 99 times out of 100, we're making that work. We're jamming it under there. We're pinching them. If it's stranded wire, we're peeling a couple strands back like banana peels, trying to get it under this little wire nut. We think we've just got it, and we close it. Whew, hopefully nobody breathes on it. Somebody comes by later. If it's internally in a breezeway fire alarm, somebody's moving a couch in there, and they bang that thing, the wire comes out of the wire nut, it's shot. Field-mounted boxes, guys mowing the lawn, hits into the box, bang, one of those wires comes out of the wire nut. We always recommend ground buses just for solid mechanical connections for that reason. I don't like to see this. I prefer to see this. Nothing in code or NFPA says you can't do it, but everybody on this call that's been in the field is shaking their head and laughing. This is the analogy I gave because we've all done it. This is the way to do it properly on the right. Installation rule number 3, you don't want to daisy chain devices together. You want a common ground bus. That's important. And then you want a thicker gauge wire from that ground bus taking you to earth ground. This is no good. This is a better installation run into a ground bus. Again, you want your protected and unprotected wires in separate conduits as well. We see a number of, projects where they pipe it into a box and then out the box into the same conduit, and then they'll just couple over and bypass the surge like this. This is a much better install. Installation rule number 5, don't put them inside the fire alarm control panel, put them in their own box. These are just installation diagrams that HW since it's installed incorrectly so much. A lot of times people will leave the leads for my device right on the terminals on the board. Well, I can tell you now, if that's the first point they join, we're 3 feet later. So looking at this picture, let's assume we don't have that bus bar there, that terminal strip. If you run the leads to my terminals on the board, and that's their first point, 3 feet later is the middle of your circuit board, and it's probably going to be cooked. That's the importance of 3 feet. Because people say, why don't you give me 3 feet leads on the HW? It's not how long my leads are, it's where it connects to the hot, neutral, and ground, or to any circuit for that matter. From that point, it needs a response time built in. Which is why a lot of times we'll say put it in a 4-square above the panel, maybe 4 or 5 feet away if you want to use this device. Or throw it on the breaker that feeds the FACP. That's a nice clean way. Ideally, I'd recommend use the one with the dry contact and the hot swappable module, because that one's pretty hard to screw up. But this one here, I want follow these best practices and you should be okay. Installation photo, giving them plenty of patch cords on the output. I know it tends to be a little extra wire, but they're gonna save your equipment. This is a field wired device. If you'll see, they kind of cool it up 3 feet of wire in that box. Doesn't need to be physically 3 feet away. Cool it up, just give you enough response time. These are just showing separate conduits in and out to keep my unprotected and protected wires, separated. This just shows the 2-position base, and we showed this ground wire. We talked about ground wires. I want to slow down here. No one will late, but this is important. I've done a number of site surveys where contractors have run a ground wire from a device like this, and let's say they came out to the left to where this bus bar is, and let's assume that bus bar is a wall. They hit that wall and they make a 90-degree sharp turn down to the bottom. They reference ground at the bottom at the floor. You don't want to make a 90-degree turn on these ground wires. Picture you're driving a car or your truck down the road at 45 miles an hour. What kind of turn radius do you need? If you think you're going to make 90 degrees, well, it's going to be an issue. So I show this slide to show you the swooping ground wires. If you need to make a turn, make a smooth, gradual turn. Clean install here, protected, unprotected wires separately, and referencing a bus bar. Multiple MHLP bases, running to a bus bar, separate wires. Again, protected and unprotected separate. Some of our electrical products installed in the field. Grounding and bonding, I'm going to spend some time on this because it's important as well. NEC code, 25 ohms maximum. The IEEE standard is less than 5 ohms. That's what we follow and we encourage our customers to adhere to. This is how we test when we're on the field. If somebody calls our company, and whether it's me, myself, Mike, any of our team, we come out in the field, we carry a 61920 ideal ground clamp meter. We can test your electrical grounds this way, or we can use a megger, which induces voltage into the ground to measure this way. It's a bigger pain in the neck, but we have the potential to do both if you need it in the field. Grounding reference point, obviously concrete encased electrode, metal building frame, rod and pipe electrodes, plate electrodes, all of these things that are provided and tied into a good solid grounding system. And then you have electrical distribution grounds. You also have, green wires right into a fire panel. Any green wire you can use as a reference. Put a bus bar on there, run your surge detectors to that, and it'll take it right back to the electrical panel. You do have to add electrodes, minimum of 8 feet in length, and they have to be bonded to the existing, building system. Especially when we get into the south, we place a lot of ground rods down here in Florida because we take lightning strikes and cook this sugar sand into glass. Avoid grounding loops. They always have to have common bond. You always want to bond these grounds together. Otherwise, you have different, difference in potential, and they're going to try and even out through the wires connecting these different panels, which a lot of times are low voltage cables, and you can have surge protection issues just because your grounds are all different. Installing surge protection and maintenance. If it's got LEDs, put eyes on them. Web portal, this is real important. It's on our website. We have unlocked data sheets, engineering design files, A&E specs, CAD drawings, white papers, application drawings, anything you need to design a project, as well as the files that are on master spec or on our engineering portal. And then, of course, for contact information, the website, we also have live chat on there. We also have a dedicated tech support team, and you can call the 1-800 number at any time. I know I went a little long. I'm sorry. I'm much better in person. Hopefully, if you have questions, Mike has done a great job of answering those questions. My contact information, jason.klein, K-L-E-I-N, jason.klein at ditekcorp.com, DITEKCORP.com. So you can always reach out to me. You can go on the website, do the chat. There's plenty of ways to reach us. I appreciate everyone being on the webinar today. And again, looking at the names on this list, some of you I've known for over a decade. And thank you so much for your support from all the way out to Portland, to Canada, to Michigan, to the core in Huntsville. We got lots of folks out there. So thank you very much for taking time out of your day. And we have another one of these tomorrow. So if you have any colleagues or anyone that you want to have this same type of training, but probably better, because tomorrow's trainer is way better than me, we have a follow-up tomorrow. Thanks again to everybody, and have a great day. Stay safe out there.